We're going to start looking at summarizing and graphing our data. And over chapters 2 and 3, some things that we're going to be interested in when we look at a set of data will be the center. Okay, and we'll talk about that more in the next chapter. We're going to be interested in variation. Okay, how consistent our data set is. Also the distribution. Okay, I think we mentioned that, but maybe not. Distribution has to talks about where the data is located. Is it all equally likely to occur? Do we have values in the center that are more likely to occur? Are values on the left or the right more likely to occur? We'll look at how we can determine that. We're going to be interested in outliers, and if it's appropriate, we'll be interested in what data looks like over time. Okay? And so they kind of summarize that as CV dot, or whatever you might want to call that, when it comes to looking at data. So anytime you have a data set, if you're doing a study, these are some things that you want to kind of look at almost right away. The center, variation, distribution, are there outliers, values that are atypical, and also time. Okay? So one thing that we can use is a frequency distribution. And a frequency distribution is a table that arranges the data values into classes. Okay, table that arranges the data values into classes. Okay, displaying the frequency of each class. Okay. Or count of each class. Okay, that's a frequency distribution. So we probably have an example of one. Here is a frequency distribution. These are the years that presidents lived after their first inauguration. Okay, and so we've had how many presidents so far? 48, I think. 44, I don't know. I don't know. Anyway, here are the classes of data. From 0 to 4 years after the first inauguration, we had 8 that lived that long. Okay, and there were 2 that lived 5 to 9 years. And we could come down here and say there are 4 who lived 20 to 24 years, and so forth and so on. Okay, so we had a lot of data. If we wanted to look at what this data might have looked like, we would have 8 values listed that had a value of either 0, 1, 2, 3, or 4. Okay, does that make sense? Okay, and so forth and so on. All right. It's a table that lists, that divides basically our data into classes, and then tells us the frequency, how many values fall into each of those classes. Okay. All right, so some things we should note, flipping over to the next page, I just want to keep this image here, about this would be our lower class limits. The lower class limit is going to be the smallest value that can belong to a class. So these are my lower class limits. Okay. And notice here in our frequency distribution that these classes are non-overlapping. A data value should belong to exactly one class. So my lower class limits are 0, 5, 10, 15, and so forth. The smallest value that can belong to this class is 15. Okay, lower class limit. The upper class limit is going to be the largest value that can belong to the class. So this second little range of values here, these are my upper class limits. Okay, those are the upper class limits. Okay, upper class limits. All right. Then we have class boundaries. Now this one might be a little tricky. Notice that there's actually a gap between this upper class limit and the next lower class limit. Right? There are numbers between 4 and 5. Right? So the class boundary is going to be the value halfway between the upper class limit and the next lower class limit. Okay, the class boundary is the value halfway between the upper class limit and the next lower class limit. Class boundary is halfway between the upper class limit and the lower class limit. Next lower class limit. Okay, everybody got that jotted down? Because we're going to find them. Okay, here we've got 4, and then we go to 5. So the number between those halfway is what? 4.5. Very good. Okay, then we got 9 to 10. So that's going to be 9.5. So the boundaries for this second class are 4.5 to 9.5. For this next one, we would do 9.5 to 14.5. Okay, these things I'm writing in blue are my boundaries. Well, all right, then we've got 14.5 to what? 19.5. Basically, if you needed to do some type of calculation, we could add the upper class limit to the next lower class limit, divide by 2. Okay, so I'll finish filling these in. 19.5 to 24.5, 24.5 to 29.5, 29.5 to 34.5, and then 34.5 to 39.5. Okay, and I would technically we'd have to say minus 0.5. Okay, we'll talk about that in a minute. Okay, but now the classes are defined so there aren't any gaps between them. Do you see the difference? And that's important, especially when we get ready to graph these things. When we make our histograms, we don't want those gaps between our classes. All right, so these are the class boundaries. Okay, after class boundaries, we have our class midpoints. The class midpoints are the values that are exactly in the middle of the class. So to get our class midpoint, we're going to add the upper class limit and the lower class limit of a single class. You can put this in the appropriate space on the handout. LCL plus UCL divided by 2. Okay, so I'm just going to add a little place here for midpoints. Zero plus 4 is 4. Divided that by 2, we get 2. Okay, 5 plus 9 is what? 14, divide that by 2, we get what? 7. Okay, very good. And then we keep on adding 5, so 12, 17, 22, 27, 32, and 37. Okay, questions about that? All right, here's the one that is probably most missed. So don't confuse this. And that would be the class width. Now, we'll talk about determining class width from a set of data. But for right now, we're determining our class width from this existing frequency distribution. Okay? And the way that we find the class width is that it is the difference between consecutive lower class limits. All right? So lower class minus lower class. That gives me my class width. Okay, the class width is the difference between consecutive lower class limits. So, when I look at this table, the difference between 0 and 5 is 5. The difference between 5 and 10 is 5. The difference between 10 and 15 is, all right, all the way down is 5. Okay? But it's not just consecutive lower class limits. You could do consecutive upper class limits. You could do consecutive boundaries. You could do consecutive midpoints. They'll always have the same class width. Okay? All right? Does everybody see that? No matter what I do. If I do 19 minus 14, we get 5. If I do 22 minus 17, we get 5. And that's what made it easy for me. Instead of having to compute each of these midpoints, once I saw that my class width was 5, I just kept adding 5. And that's going to be really useful for us when we get ready to construct our own frequency distributions. Class width, from a frequency distribution, it's the difference between consecutive lower class limits. Okay? Difference between consecutive lower class limits. But you could replace lower class limits with upper class limits, or midpoints, or boundaries. Okay? All right, very good. Okay, 3 reasons for constructing a frequency distribution. They listed them very clearly in the textbook. Let me go back and look. Let's see. Okay, they said summarizing large data sets. Okay, gives us an idea of what's in that data set. Okay, so that we can analyze the data to see the distribution and identify outliers. That would be the second reason. Okay, we want to see the distribution. We want to be able to identify outliers. Okay, and the last reason would be so that we can construct graphs. Okay, all right. So the first was summarize large data sets. That's one reason. Okay, the second reason is we want to analyze the data to see the distribution and identify outliers. And the third is for constructing graphs. Okay. All right, in the next part about frequency distributions, we want to construct our own frequency distribution from a set of data. All right, so let's go back to our handout. I lost my handout. Okay. Here, again, kind of an outline. This is different. We're constructing our own frequency distribution. So here's some steps. We're going to select the number of classes, usually between 5 and 20, but it really depends on how much data you have. Okay, the more data you have, then the more classes you can have. But if you have too many classes, then your data values will be too spread out and you don't see a pattern. So sometimes you have to kind of play with it. Okay. As far as test purposes, I'll tell you how many. Okay, I know that's the main question, so I'll let you know. Then we're going to calculate the class width. We don't have a frequency distribution to look at, so how do we figure out what the class width is? Well, the way we do that is we're going to look at the maximum value minus the minimum. divided by the number of classes. And then we're going to round up. Always round up for this. Okay, round up. Okay, round up. All right, then we'll choose the value for the first lower class limit. It could be the minimum value in our data set or something slightly less than that if it's convenient. For instance, if your class width comes out to be 5, and your minimum value is 11, you might as well let your minimum value be 10. So we can, add the 5s and 10s. Does that make sense? Yes? Okay. No? It's easy to add. It's just kind of natural to add 5 to 10 than to 11. So, again, I would tell you what I want you to use as your minimum for the test. But otherwise, yeah, right. No, yeah. On the test, I would tell you that again. Okay. Then we're going to use the first lower class limit and the class width to list our other lower class limits. We're going to list the lower class limits in a vertical column, determine the upper class limits, then we're going to determine our frequencies. Okay, so I went to our data that we've collected so far for this semester. I found about 52 responses there. So I copied and pasted them into the notes here. And we're going to construct the frequency distribution of the ages of 52 Math 120 students. We're going to use 7 classes. I didn't play much with this, but at 52 values, 7 classes, that gives me potentially 7 values per class. Okay, so we'll see what that looks like. And we'll use the minimum value as the first lower class limit. So you know how many classes, what your first lower class limit should be. Okay, and then it also mentions the relative frequencies and the cumulative frequencies, which we're going to try to get to in 10 minutes. Okay, but so looking through the data set, what do you find is our minimum value and our maximum value? Okay, 18 seems like the minimum, and the maximum is what? Okay, very good. I'm going to cheat a little bit. Okay, so you said 18 and 51. So my class width is going to be 51 minus 18 divided by 7. That comes up to what? 4 point something? Okay. Approximately 4 point something. Which we're going to round up to. Okay. All right, that's good. So we're going to round up to 5. Okay. Even if this thing came out to be 4.1, I would still round it up to 5. Always round up. Okay. Otherwise, it won't work. Okay. So we got our class width. We said it's 5. Now we're going to choose. It tells us the minimum value is the first lower class limit. So 18 is going to be my first lower class limit. Well, remember, the class width is the difference between consecutive classes. So I don't have consecutive classes, but I do have the first value, and I've got a width, so I can use that to get the next one. So my next lower class limit is going to be 18 plus 5, which is what? 23. And then I add 5 again, 28. And I add 5 again, 33, 38, 43, 1, 2, 3, 4, 5, 6, 48. Okay? Those are my lower class limits. Now we need to come up with the upper class limit. Everybody with me? Okay, good. All right, so to get my upper class limit, I'm just going to use a little deduction here. This class starts at 18 and the next one starts at 23. So this class must stop where? 22. And still, I can use that class width to get the other upper class limit. So we get 27, 32, 37, 42, 47, and 52. Okay, those are the lower and upper class limits. Okay, so I've got my classes now. Okay, the next thing I would want to do then is determine the frequencies. And that's where I said we're going to cheat a little bit. Okay, I've got these data values in my spreadsheet, I think. And so at least I can use Excel to sort the values. Okay. So here they are in the column, and I think we talked about sorting the other day. Just click that A to Z button. Oh, and it didn't sort the first value because it thinks that's a header. So I'm going to click on this, deselect headers, and then sort it again. And now it's got it. Okay. And so since my first class goes from 18 to 22, is that what we said? Okay, then one thing I could do is just kind of highlight. And right here in the upper left corner, you see it says 23 rows by one column. That's how many values I have there. So my frequency for the first class is 23. Okay, write that down. Otherwise, you can just count them. Okay, but I'm trying to be smart about it. All right, then for the second class, we got 23 to 27. So if I highlight that, that's going to be 10 values. Then we got 28 to 32, 11 values. 33 to 37, 3 values. 38 to 42, 4 values. 43 to 47, no values. And 48 to 52, 1 value. Okay? Well, normally, I mean, I would... Without what? Yeah, I mean, you could go through the data and say, that'd be the long way. Right. Tally it up. But if you got it in a, in a spreadsheet or something like that, at least sort it. That's going to help you a lot. So either way, we got to count it. All right, very good. So y'all got those, right? Okay, tell me what they are. Yeah, hold on. Let me get back over there. Where's my stuff? Okay, our frequencies are what? 23. Uh-huh. And 1. Okay. All right, very quickly, let me just mention to you what the relative frequency is. Relative frequency is just percentage. You can write it as a percentage or decimal. When I add these up, just as a check, we should do that. Hopefully they come up to 52. So if I wanted to talk about my relative frequency, I'm going to take each frequency value divided by the total. So whatever 23 over 52 is. Okay, we would put that decimal value there. 10 over 52. Okay, 11 over 52. 3 over 52. 4 over 52. Okay, I can tell you this one is 0. And then 1 over, 52. 52. Okay. So percentages and relative frequencies, you're probably fine. And again, you can write that as a decimal or as a percentage. Okay. Here's the cumulative frequency. Okay, cumulative frequency counts the number of values in the class that I'm looking at and in each of the previous classes. Okay, so for instance, for the first class, my cumulative frequency is 23. For the second class, it's going to be 23 plus 10, or 33. Okay, we're accumulating all of the frequencies as we go down. So I can say that there are 33 students who are 27 years of age or younger. Okay. The next one would be what? 44. Okay, we add the 23, 10, and 11. And then we get 47, 51, 51, and then finally 52. So by the time we get to the last of our cumulative frequencies, that should be equal to our sample size. Okay?